Hello, my name is Harivarsha Analaki Suresh. My matrix number is 08DEP20F2028.
Assalamualaikum and hi, my name is Mohammad Nabil bin Naina Mohammad and my matrix number is 08DEP20F2026.
Hi, my name is Nitruban. My matrix number is 08DE. Differentiation is widely used in science and engineering field. It can help us solve many types of real-world problems. Some applications of differentiation rotation include tangent and normal is Newton's method rate of change, finding maximum and minimum points, and curve sketching. In this presentation, we will discuss about finding stationary points by using differentiation and also learning to sketch a graph.
Okay, now let's look at a stationary point question. Our equation for the example question is y is equals to x square minus 4x plus 1. So we're going to follow a 3-step method. So step 1, we need to find the derivative function. So I'll just write find dy dx. Then we will write our function here back, which is yx square minus 4x plus 1. So to differentiate this, we're going to use a known power, which looks something like this. So when we do this, x square becomes 2x, 4x becomes 4, and of course the 1 vanishes when we differentiate it. So that settles step 1. Then we go to step 2, which is now solving the equation. Remember, at stationary point the derivative function is 0. Since the derivative is 2x minus 4, we need to solve the following equation. So 2x minus 4 is 0. Then we need to solve this equation for the x. So 2x equals to 4 and x equals to 4 over 2, and finally we get x is equals to 2. So in total we can say that the curve has one stationary point and its coordinate is 2. Okay, now we can go to step 3. In step 3, we basically need to find the y coordinate of its stationary point. The function is already given, but remember, the x we already found the coordinate for it. So when we replace it, it looks like 2 square minus 4 times 2 plus 1. So 2 square becomes 4, 4 times 2 8 and 1. So when we finally summarize it, in total we get y is equals to negative 3. Now we can confirm by looking at this that this function curve is 2 negative 3. Now we can confirm this by looking at the function curve, which looks something like this. Looking at this curve, we can say this curve has a stationary point at 2 negative 3. That's it for this question. Thank you.
Now, I'm going to show you rate of change in differentiation. Rate of change in differentiation as the derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding slope of the tangent line to the function at a point. So now, without wasting any further time, let's see an example question. So here I have an example question. The side of a cube is increasing at the rate of 5 cm per second. Find the rate of increase of the cube when the length of a side is 3 cm. So when we have a question like this, we need to do a sketch. So it is stated that a cube. So we just draw a cube. And we label the side with x. Therefore, the volume is equals to x cube. So here we need to find dv over dt. It is given that x equals to 3. Meanwhile, the dx over dt is equals to 5. So the formula here is that dv over dt equals to dv over dx multiply dx over dt. So it is equals to, the volume of the cube is that x cube. Here, so we will bring the 3 in front and minus 1. So it will be 3x cube. And it is given that dx over dt is 5. So we put a 5 and we put bracket for both of the number. So here we have 15x with a cube. So it is given that x equals to 3 centimeter. So dv over dt equals to 15, 3 in a bracket, square. So here we get an answer 135 cm cube with the s negative 1. So it is stated that the side of a cube is increasing as the rate of a change becomes 135 cm cube over second. So it is easy to use the formula I just given before. Therefore, that's all for my example.
In conclusion, an equation is in explicit form when one variable is directly equal to an expression made up of the other variable. Next, an equation is in an implicit form when neither variable is isolated on one side of the equal sign. Lastly, find the derivative of a relation by differentiating each side of its equation implicitly and solving for the derivative as an unknown.